Okay, this is Tutor PBS. Welcome to another tutorial under chemical kinetics, where we have this type of question here. I think if you want, you can pause the video, then write down the questions. So these are the questions A, B, C, D, so that we can progress nicely. So we are saying we've been given this information, the experiments are 1, 2, 3. We've got the concentrations for each reactant. We also have the initial rates for each experiment. Then we have been given the general rate expression K, concentration of F to the power M, concentration of ClO to the power N. So how exactly do we find the values of M, the rate law expression, the overall reaction, and the rate constant with its units? All right, so it is very easy. So what we do is we can compare reaction rates. All right, so let's go to experiment 1. If I get experiment 1 and experiment 2, these two are cancelling out, so I can work out with these two, which is fine. All right, so the only thing we are saying that get the ratio of these two. So get, this is part A, so get rate 2 divided by rate 1. So when we say rate 2 divided by rate 1, what do we mean? So here is what we mean. So rate 2, of course, is following this experiment there. So we have 4.8 multiplied by 10 to the power negative 3 is equal to F is starting, by the way, F is starting, so we are starting with this one, then end with that one. So we have 0.1 to the power M, then we have 0.04 to the power N over rate 1 is 1.2 times 10 to the power negative 3. Here we still have the same 0.1 M, then 0.01 N. Oh, there's a K here and a K here. Of course, those are going to cancel. So now we have 4.8 negative 3 divided by 1.2. So I'm getting 4 here. Even here it will be 4 to the power N. So the value of N is just 1. We need to find M. So for us to find M, we know that we can use this experiment 1 and 3 because these two can cancel. So we can say rate 3 over rate 1. What do we get? So this will give us rate 3 is actually 2.4 times 10 to the power negative 3 over rate 1 is 1.2 times 10 to the power negative 3 is equal to K, even down here K. So we have this type of expression. What we have here, M, N, M, N. So you can see that the value of M would differ, right? The value of M would differ because we are getting 0.1 and 0.2. So we have 0.2 and 0.1 there. Clear, right? But the value of N will remain the same because this is the same and this is the same, 0.01. So 0.01, 0.01. So gone, including the K. So this one into there, this one will give us 2. This one will give us 2 to the power what? M. Even the value of M is 1. So we have found the value of what? So therefore M is 1 and N is 1. So we found the values of M and N. So part A is done. Let's go to part B. Part B says write the rate law expression. So our rate to be K, concentration of F2, concentration of ClO. That's all. Why? Because M and N are now known as 1 and 1. So if we put power 1 there, it used to be the same, right? Let's go to part C. Part C is saying determine the overall order. All right, so the overall order, all right, overall order will be equal to m plus n. What is m? 1. N 1, so 2. That's the overall order. Then D, determine the what? The rate constant. To determine the rate constant, what we have to do that, get n of the react or n of the experiment here. If you want, you can even get experiment 1. It's up to you, by the way. All right. If you want, you can get experiment 3. It's really nothing. So if you get experiment 1, okay, we know that our rate is equal to K F2, like that. Our rate from experiment 1, is actually 1.2. Is 1.2 times 10 to the power negative 3 is equal to K. Concentration here is what? 0.1. I think I've remembered. And for that one, it was different. It was 0.01. So we have 0.01. So let's go 1.2 times 10 to the power negative 3. Multiply these two. What is it requiring? Just requiring us to shift one decimal point on 0.1. So get 0.001. Like that. So we divide by 0.001. 0.001. So K dividing these two. Let's go. So I'm getting 1.2. But remember the units. What are the units for rate? The rate has these units. MS. The rate has got MS. So here we have M stroke S. But what about the concentration? The concentration is actually more per liter. All right, so the concentration is more per liter. Now we were multiplying them. So you discover that more per liter is just molarity, by the way. In case you don't know, more per liter is just molarity. So here we had M squared. Even here we have M squared, like that. So because of this, we get M -1 and S -1, which you can just say K is equal to 1.2 per meter, per molarity per second. It's up to you, whichever. So basically the question is done. You see how easy they are? Simple and straightforward.